So guys, in this video, I would like to explain about random experiment in statistics. You may know about the experiment, but we will talk about random experiment which we use normally in statistics. And you may know that random variable as the concept which has the origin from the random experiment because the values of the random variable can be determined by the outcome of the random experiment which is the basis, of course, in statistics. So let's see how we can define random experiment, and then I will give some example from the real life about random experiment. Uh, okay, let's see. In statistic, a random experiment is the process or procedure that produces an outcome that cannot be predicted with certainty in advance. The basic steps involved in conducting the random experiment or define the experiment are clearly described the process or event under study, identify the factors influencing the outcome. And these are something you can see. Okay, and let's see, we can. Okay, now identify the sample space. Okay, list all possible outcome of the random experiment. So let's first talk about the definition. And statistical random experiment is a process of producing that the pro, the, pro, the that produces an outcome that cannot be predicted with certainty in advance. The basic step. Okay, so this means that this can produce the outcome which cannot be produced, which cannot be predicted with certainty. Just like when you're tossing a coin. So in that case, you say, okay, let me open one note so then I can write. Okay, so this means that when you are tossing a coin, so you cannot say that will be head or that will be tail with certainty. So in that case, you may get a head or you may get a tail. Like I will say, this give me the example. You can say when you are tossing a coin, so that the output may be head or tail. So there is a probability of head and tail that for each for an unbiased coin that is 1 divided by 2. Remember, if the coin is biased, then this probability will not be equal to 1 divided by 2. So this is for unbiased coin. And similarly, if you roll a die that has 6 sided, so in that case, the probability of each side, suppose I will say that event A represent a side of the die, that will be 1 divided by 6, because the total number or total sides of the die are 6. So you cannot say with certainty that's true. That's the definition that it will be 1, 2, 3, 4, 5, or 6 in advance. So this is the definition. Now you need to identify. Let's go back to the slides, and you can see that. Okay, clearly describe the process of the event under study. So yes, you can do like this. This is the coin tossing. This is the die rolling or any other thing. And identify the factor influencing the outcome. So this may be, the conditions should be identical for random experiments. Maybe you're tossing a coin on the grass, and on the other time you're tossing a coin on the floor that can produce different results. So the condition should be identical for random experiment. Now you can see you can list the sample space. So let's do this for our experiment. I mean, for this one, for the first experiment of, you know, tossing a coin, tossing toss a coin. Suppose 2 times. So that means the sample space we denote by S, and we can write like this, and then the outcome. So on the first coin there can be tail, and the second coin there can be tail. This is the potential output. The other output can be the first coin is tail, the second is head. The other output can be the first is head and the second is tail. And the last output can be that both can be head. So this is, now you can see 4 outcomes, and that you can say the output, the sample space, the total sample space of the random experiment when you're tossing a coin 2 times. And suppose when you're tossing a coin 3 times, then the sample space can be a bit different. I mean, with the more outcome, that can be like 3 heads, 3 tail on the first, the second, the third, and then maybe you can see tail on the first and the second, and head on the third, and then maybe there is tail, head on the second, and tail on the third, and then there may be head on the first, tail on the second and third, and then maybe there is 1 tail. You started from 3 tail, then 2 tail, and then maybe there's 1 tail and 2 head. Actually, this is the possible outcome. And then there can be head on the first, tail on the second, head on the third, and then there can be head on the first, head on the second, and head on the third. And the last can be head on each of them. So 1, 2, 3, 4, 5, 6, 7, 8. There are 8 possible outcomes. Remember that you can find the number of outcome by the formula, number of total outcome. Total outcomes that is equal to 2 power n. N is the how much time you repeat it. Maybe you can write k instead n. K is the number of time that you are repeating the experiment. So 2 power 3 times you are repeating this experiment. That is equal to 2 multiplied by 2 multiplied by 2, that is equal to 8. Similarly, you can do for the above experiment, that is 2 times. In that case, that is equal to power k 2 power 2, that is equal to, that is 2, so that is 4. You can do this for higher order as well. And similarly, if you die or you roll a die, for that, roll a die. In that case, you have the sample space. That can be 1, 2, 3, 4, 5, or 6. And if you want to repeat this experiment, and this is now, remember that now this has 6 possible outcomes, and the k is 1. The above has 2 possible outcomes for the 1 trial, and power is k. K is the repetition of the experiment. In that case, k is equal to 1. So k 6 equal to 6 power 1 is equal to 6. And similarly, if you are doing for k equal to 2, that means 6 power k equal to 6 power 2, which is equal to 36. We don't write here because you can write this, no problem. So this is all about random experiment. That's what is meant by random experiment, which is the basis, for to provide the values to the random variable. In the next video, we will talk about random variable, and that's generate the values from random experiment. And you will see, we will use the same example, and you will see the random variable will take the values from the random experiment. So this is all about today lecture, and thank you very much, and see you in the next video. Ciao.